Hello, this is question 3 from the 2011 MAT. The graphs of y equals x cubed minus x and y equals mx minus a drawn on the axes below. Right, so we've got a straight line, we've got a cubic. M is greater than 0 and a is less than or equal to minus 1. The straight line meets the x-axis at capital A, so that is coordinate little a. So that value there, that is little a, and touches the cubic at B. So this is our tangent. Intersects again at C, fair enough. The coordinates of capital B and capital C are little b and little c. Right, they're the x coordinates. Right, so all that is marked on. Use the fact that the line and the cubic touch when x equals b to show that m is that. So we've got gradient of a straight line at B equals gradient of cubic at B. So that's what we wanted to do. So the gradient of the straight line, well, that's m everywhere. Gradient of the cubic is going to be 3b squared minus 1. Oh, right, well, there we go. That was that done. Show further that a equals all of that. Right, so how did a come into all of this? So we've got what m is. Oh, we're just going to be dumping some of this in, I would have thought, and seeing, so because we want to get what little a is. These are intersecting each other. We know what the value for m is. So at b, yeah, this is where all of this meets. So excellent. Right, so we can say at b, we've got that b cubed minus b, that's our y value for the cubic, is going to be equal to m, which is 3b squared minus 1, times b minus a. So we just have to make a the subject of that by the look of it, and then we're all okay. So how have they decided to arrange all of this? It's, I don't know. I mean, I just want to divide through, leave the b there. Okay, so anyway, we've got a is b minus b cubed minus b divided by 3b squared minus 1. So is that going to get anything like this by the time we finish with it all? So we've got the 3b squared minus 1 bit there, but we've got 3b cubed minus b cubed, so that's 2b cubed, and then minus b plus b. So yeah, it does come out exactly as we want. 2b cubed over 3b squared minus 1. Okay, so that was fine as well. If a is minus 10 million, so that's a big value for little a, what is the approximate value of little b? So we've sent this off into the distance, onto the left. So we're more or less getting a flat line. Yeah, it's going to be more or less no gradient here at all on m. So as we're sending a off, to the middle of nowhere, we're now going to be getting the gradient being more or less 0. So that means that, right, let's write some of this out. As a goes to, was it minus 10 to the 6, m is going to be tending towards 0, which means we've got 3b squared minus 1 tends to 0. So b squared will be equal to, well, root of a third is what we're going to be getting of this. But it's got to be, we're going to have a plus or a minus. Oh yeah, because we could be going either side on these, but we know that b is negative. B squared equals, where was I? A third. And b is less than 0, so b is roughly equal, that should be roughly equal to the negative square root of a third. Okay, I'm quite happy with that. Then so that's done that bit. Run out of space, let's get a fresh sheet up and say, right, using the fact that x cubed minus x minus m, oh god, all this stuff here, which you do not need to prove, show that c equals minus 2b. Well, imagine we just have to square this out, multiply everything out, compare coefficients, maybe, I don't know. So let's expand. So what have we got then? We've got x cubed minus x minus m x minus a, and that is equal to, so we've got x squared plus b squared minus 2bx, then multiplied by x minus c. Okay, so we are going to get some terms that we can compare. So x cubed minus what have we got there? 2bx squared plus b squared x. So it's done all the x bits, minus cx squared minus where am I now? I'm trying to put them in order. That's why I'm not just going x squared, b squared, and then 2bx. I'm trying to get them in coefficient power of x order. So plus 2bcx, and then minus cb squared. So that's our x cubed minus x minus mx minus a. All right, so we got some x's there as well. What ones are we trying? We're trying to show that c equals minus 2b. How are any of these going to match up then? So, oh, well, we don't have any x squareds, so that's something that we've certainly got in all of this. So compare our x squared terms. So for our x squared coefficients, we've got, because the cubes are just cancelling, that's fine. But for x squareds, we've got a 0 on the left-hand side. We've got a minus 2b minus c. I think that's all our x squareds, it is, isn't it? So what are we after? Oh yeah, there we go. So c is minus 2b. Right, so we did get that come out. And then the last part, R is the finite region. Oh yes, bounded by the line, so it's between the straight line and the cubic, right? For what value of A is the area of R largest? So what are we doing then? So we're moving, well, as we move A that way, it gets smaller. As we move that way, it gets bigger. We move this across here, then our line's going to be going up like this. So that's what we want to do. We want to move A across until it's actually at B. That'll be where it is the tangent. So right, so we got R is largest when A equals B. Right, yeah. And what value would that be? That's going to be at -1 for x. So we've got all of those. So what am I trying to do? That's the value of A for which is largest. Right, I've done that. Show that the largest possible area of R is 27/4. So how are we going to get this area then? So these are going to keep going up here until they're going to intersect. Right. So where are they going to intersect? I suppose that's the next thing that we want to know. So they intersect at some value c, little c, and little c is minus 2b. So c is going to be equal to 2. Okay, so we're going from -1 up to 2. We got a big triangle. Let's try and think. So we've got the big triangle underneath the straight line. Then we've got our cubic. So the cubic is coming up and then down and then up there. Okay, I've made that a little bit wonky. I was going to end up drawing it through the bottom of the triangle, but it doesn't go through the bottom of the triangle, it goes through 1. So we've got to take off that area, add on that area, take off that area. That's what we end up having to do. Right, so yeah, because that's going to be a negative in terms of the area R. That's going to be a positive, and then that's going to be a negative. Is this, so total area, I'm just wondering if these are going to be the same. This is going to have, what was our cubic? Because it's got rotational symmetry. As in, is that area there the same as that area there? And it will be, because if we've got f of x equals x cubed minus x, f of minus x is going to be minus x cubed, and then yeah, it's going to be minus x plus x. That's minus of this. So we've got f of minus x equals minus f of x. So yeah, we've got rotational symmetry here. So these are just going to cancel out. So that's fine. We just need to take off this bit because these other two areas are the same. So we can say the total area is equal to the area of the triangle minus, not equals, minus the integral from 1 to 2 of x cubed minus x dx. It's probably worth putting a note on there saying that the area of cubic between -1 to 0 equals the area of cubic from 0 to -1. I mean, you can write that in a lot of different ways. I suppose I'm just leaving some space over here so I can actually do this. You might want to say that the magnitude of the integral of x cubed minus x dx from -1 to 0 is equal to the magnitude of that same integral from 0 to -1. So they're just going to be cancelling out. So we just have to do this bit. The area of the triangle is half the base, and that's going from what, -1 to 2. So it's a half times 3 times the height. And the height is going to be whatever it is when x is 2. So that is 2 cubed minus 2 is 6. So that's the area of the triangle. Then we've got this. So that is going to be x to the 4 over 4 minus x squared over 2 between 2 and 1. So that comes out as 9. And then we have to take off all of this. So that is going to be 2 to the 4 divided by 2 squared. So that's 4. And then take away 2. Then we've got to take away a quarter and then add a half. So that is going to be 2 plus a quarter. So 9 minus 2 1/4 is 6 3/4, which is equal to 6 3/4, which is 27 over 4. But I just don't like using top-heavy fractions. But there we go. That's come out okay. A little bit messy on the page, but providing you've made a note of that and you've actually alerted them to the fact why you're discounting those two regions, and that last part is okay. Quite like that as a question. It gives you something to think about. What's going on with this particular, in part 3, what's happening to A? And I suppose it's the same thing then in part 5. In one of them we're moving A off to the left, and the other one we're moving A off to the right. So we're minimizing the area, maximizing the area, minimizing the gradient, maximizing the gradient, and then just working everything off of that. So that was a nice question. I like that one.